Welcome back to McMaster Start Coding and to the introduction of the 3D slot on MacOutreach.rocks. Having a solid grasp on coding 2D shapes will be super helpful when learning how to code 3D shapes. So if you don't know how to code 2D shapes, watching lessons number 1 to 6 might be a good place to start. These lessons can be found on our YouTube channel. First, let's head to MacOutreach.rocks and log in. Remember that your username and password are case sensitive, so you have to use capital letters wherever you need them. Once you put in your username and password, you'll need to head to the 3D slot. It's this cube icon here. You can head to any number slot, but avoid slots number 10, 11, and 12, because these slots have code for the creation of a B game, which is the focus of one of our camps. We won't be using those slots today, because today we're just going to focus on the basics of the 3D slot, including the materials, shapes, and transformations used. So I'm going to head to a slot that I've never used before, which is slot number 15. So each slot comes with code to help you get started, and there are comments throughout which will guide you. I'm just going to click compile so that we can see what our default code looks like. You can use your mouse to change the camera view if you want to, and if you want to go back to the original camera view, you can just click this reset button here. Okay, so let's do a really quick overview of the code, and then we'll go back and we'll dive in deeper and see exactly what each chunk is doing and what it corresponds to. Starting at the top, we have something called My Entities, and this is similar to My Shapes, which we've seen in lessons that use the animation and game slots. Here we have some example shapes. Looking further, we have some code that corresponds to the light. So for the light, we can change the position, the chromaticity, and the intensity. We can also decide if we want the light to show or if we want it to be invisible. Beneath that, we have code that corresponds to loading textures. Then we have a place where we can overlay 2D shapes onto the screen. You can add as many 2D shapes as you want into this list. In our default code, we have one circle that's filled red, and we can see it right here. So no matter how we move the camera, we'll see that the red circle is on top of everything else, and that's because it's overlaid onto our screen. Below the overlay code, we have code that corresponds to the floor, so we can play around with the color and the floor size. And then lastly, we have code that corresponds to the skybox, which again we will get into later. So I'm going to head back to the top, back to my entities, and we are going to explore this a little bit further. So I'm going to erase the sample code just so we can start writing our own. Okay. So each 3D shape consists of a mold, which is similar to a stencil for 2D shapes. Some basic 3D shapes include a box, a cube, sphere, cone, or a cylinder. Each mold must be given parameters corresponding to the shape dimensions, just like 2D shapes. And again, the shape can give you clues as to how many parameters you will need. By default, all shape parameters are in centimeters. 3D shapes must also have a material applied to it, and this is what turns our molds into objects. Each material must also have a color. Basic materials include plastic, metallic, and matte. When you're using a plastic or metallic material, you must specify a roughness, which is a number that ranges from 0 to 1, in addition to specifying a color. A high roughness will give you a duller appearance to the material, and a lower roughness will make the material appear more shiny. So let's try making a shiny blue metallic sphere with a radius of 25. So we'll start by putting in our mold, which is a sphere, followed by our shape dimension. So here we'll do 25. Then we need to specify the material, followed by a color and a value for our roughness. Since we want a shiny material, we're going to use a really low roughness value. So I'm going to put in a forward pipe, and then I'm going to put in my material, so I'll write metallic. And then I'm going to specify my color. So for color, I just write color dot, and then whatever color I want to use. So I'll use blue. Then for my roughness, I'm going to use a very low value because I want a shiny sphere. So let's hit compile to see how it looks. Okay, so we have our shiny blue sphere. Notice that when we specify a color for a 3D shape, we have to write color dot the color we're using, rather than just the color like we do for 2D shapes. This is because our 3D shapes use a different color set than our 2D shapes. 2D shapes in this slot just have the color, and we can see this in overlay here. We just have circle 10 filled red rather than color.red or something like that. So I'm going to scroll back to the top, back to our sphere code. You can play around with these values to get whatever you want. For example, if we wanted a dull sphere rather than a shiny sphere, we could change our 0.3 into a 1. And now when I hit compile, we'll see that we get a really dull sphere. We can also use custom colors for our 3D shapes, just like our 2D shapes. So we can use either HSL or RGB, which stand for hue, saturation, and lightness, and red, green, blue, respectively. We can change our blue into a custom HSL, so let's try that out. For our 3D shapes, our HSL values will all range from 0 to 1. So you can just play around with these numbers to get the color you like. Just as a reminder, hue corresponds to color, saturation kind of refers to the color purity, and lightness corresponds to how light or dark the color is. We usually use 1 and 0.5 for saturation and lightness respectively. So here we can write color dot HSL, and then we just need to follow HSL by the 3 values that we want for H, S, and L. So for H, I'll try 0.6, for S, I'll do 1, and for L, I'll do 0.5. And then I'm going to change my roughness back to 0.3. Now I'll hit compile, and this is what my shape looks like. So it's still blue, but it's shiny. And then you can just keep experimenting with our different values here, or you can look up a color picker to help you decide what exactly you want. So 0.1 corresponds to this yellow gold kind of color. We can also animate color like we did in lesson number 3 by replacing our hue value with model.time. So let's try that. We can also multiply model.time by whatever we want to make our color change fast or slow. So I'll make it a little bit slower, so I'll just multiply it by 0.1. Then I'll click compile, and you'll see that we have this cool color changing sphere. Okay, so I think we've got a good handle on our basic 3D shapes. Just as a reminder, you can check out all of the basic 3D shapes on the documentation that's linked in the description. So let's move on to our complex 3D shapes, like rings, ellipsoids, and polycones. So complex shapes are similar to the basic primitive shapes that we've been using so far, but they require the generation of a custom mesh. So primitive shapes are predefined in the Elm 3D Scene library, so we don't need to make meshes for those. So let's try making a complex shape. We'll try making a ring. So a ring is a shape that takes in 2 parameters which correspond to the radius and the thickness. So let's go in and write our mold and our parameters. So I'm going to write ring, and then for radius and thickness, I'll use 50 and 20. Then, because this is a complex shape, I need to generate a mesh. So to do that, I'm just going to write model.meshStore. Then, just like the primitive shapes, I need to have my material and my color. Okay, let's hit compile and see how it looks. So constantly generating meshes would really slow down the slot, so first we check to see if the mesh has been generated already, and if it hasn't, we generate a mesh and we store it in model, like we see here. If you created a function, you would have to pass model in as a parameter. So let's see what that would look like. We could make a function here, for example, called a ring, and we would have to pass in model, so I would just write model like this, and then I would have my code for the ring. And then whenever I write a ring up here, it must be followed by model because I'm passing that in here. I'm going to click compile. Okay, so now we have our ring, but it goes through our floor. So now might be a good time to introduce our first transformation. So we can use the move 3D function to move our ring up a little bit just so it's not going through the floor. This is similar to our 2D move function, but now we have to specify an X, Y, and a Z position. And to move our shape up, we simply just have to increase our Z from 0 to something a little bit bigger. And I see that my ring is no longer going through the floor. If you're having a hard time visualizing which direction you need to move your shape in, you can make a set of axes out of cylinders. Cylinder is a primitive shape that just takes in radius and height as parameters, so you just need to have 3 cylinders, and then you need to rotate them according to which axes you want the cylinders to line up with. We can rotate using Rotate 3D, which takes in a pitch, yaw, and a roll. These are aircraft principal axes, and you can learn more about them by looking up a diagram. But you can also use rotation functions which correspond to each specific direction. So these are called Rotate X 3D, Rotate Y 3D, and Rotate Z 3D functions. So this should be our X-axis. This should be our Y. And this should be our Z. I'll hit compile, and we see our 3 axes. Again, this isn't necessary, but it can make moving your shapes easier if you have a hard time visualizing the movement. Okay, so now that we've reviewed some basic primitive and complex shapes, let's look at making some other shapes like the polycone and polycylinders. So a polycone takes in a list of points and a tip for the shape, and a polycylinder takes in a list of points and a height. So the tracing tool might be useful when compiling a list of points, and we can find the tracing tool in web page slot number 4, 5, or 6. Okay, so I'm going to head to slot number 5, and I'm going to click compile, and when I click compile, it gives me instructions. And you can read these instructions more carefully if you want to, but for today, I'm just going to quickly trace, just so I can show you the gist of how the polycylinder and polycone work. So basically, I have my image URL here. You can get any URL you want, just get the image address, paste it here, then adjust the positioning of the picture so that it fits nicely on the screen. And then to trace, basically, you just need to tap a bunch of points and get the general outline of your shape. You probably want to trace more carefully if you want a nicer shape, but for today I'm just going to go really quickly. Okay, so once you've tapped all your points, you just need to click close, and then you also want to click this so that we generate a list of points for a polygon. I see that my points are all showing up here, so to get those points I'm just going to click Control A or Command A. Basically I just need to select it, then I need to copy my points and paste them here. I can also fill my polygon red if I wanted to, just so that I can see how my traced shape looks. I didn't need to fill it in red because I don't even need that section of code. I just need this list of points, but it's nice to see what my tracing looks like. So I'm just going to copy and paste my list of points from this slot into the 3D slot. Okay, I'm back in the 3D slot and I'm just going to click compile. Now let's go in and add our polycylinder. So for a polycylinder, I just write polycylinder, followed by a list of points and a height. So for the list of points, I'm going to make definition here, and I will just call this leaf. That way, up here, I can just simply write leaf. For the height of the polycylinder, I'm going to use 10, and then because this is a complex shape, I need to make a mesh. Then, just like all the other shapes, I need to have a material and color and maybe a roughness. And that's what my shape looks like. If for some reason you're running into the problem of some of the faces of the shape not being visible, you could solve that problem by simply reversing your list of points, and you can do that by either tracing your shape in the opposite direction or using list.reverse on your list of points. Okay, so now let's look at how to make a custom texture on our shapes. Let's erase our polycylinder and go back to the sphere that we had before. Okay, now to make our sphere textured, we can just erase all of this here and replace it with our texture. So I'll write textured, and then use texture, and then the name of the texture I want to use. So by default, this slot already has a texture made called squares, so let's try using that. You can also make your own texture if you want to. Know that when you're making a textured shape, it must always be followed by a roughness and metallicity. So here, I'll just do 0 and 0. So I'll click compile, and that's how my squares texture looks on my sphere. You can also play around with making your own textures. You can kind of just follow along with the format seen below here. You can also use a URL for your texture. We have a list of URLs for you to use. You just have to check out the video description. Here, let's try using one of those. So I'll get the Minecraft grass texture for the sphere. So I have my URL, so I'm just going to load my texture. So I'll just follow the same format as above. Now I can just scroll up and I can replace squares with grass. And now I see that my sphere has the Minecraft grass texture on it. Okay, so I think that about covers textures. There's a lot more information in the documentation, which again you can find in the description. And the documentation also has a link to a bunch of URLs that are ready for you to use, so you can check that out as well. The last thing that we'll look at is the skybox. So I'll scroll down to the skybox code. So it takes in a URL skybox, and then it takes in 6 values, which are seen at the bottom of the page. So we have texture bottom, texture top, texture side 1, 2, 3, and 4. Then we scroll down, and we have all of our texture bottom, top, side 1, 2, 3, 4 here. So you can just insert URLs here to make up each side of the skybox. If you don't want to use a cubic skybox, you can also use any of these skyboxes here. So I'll just comment this out, and I'll uncomment another type of skybox. So this first option here is a graphics SVG skybox, and it takes in 3 2D shapes and uses them to create the skybox. So I'll just click compile, and that's what this skybox looks like. So it has our skybox top, skybox sides, and skybox bottom, which are all here. So we can also look at our other skyboxes, so I'll just comment this one, and I'll uncomment this one. So for our spherical skybox, it only takes in the skybox top. So that's what it looks like. And then we have our last skybox here, which takes in a URL. I'll click compile. And just by default here, we have a link to the Milky Way skybox. So that's what it looks like. Again, you can check the description for other skybox options to use. Okay, so I think that about covers the basics of the 3D slot. So you should take some time to explore the slot and the documentation in the description. Okay, so now it's time for an activity. This activity consists of 4 sub-activities or challenges that build on top of each other and get a bit harder as they progress. So use the documentation in the description to help you along. The documentation includes all the primitive and complex shapes, all the materials, and all the textures and all the transformations, basically everything you need to help you along through the challenges. If you need help with something, feel free to use the portal on the bottom right of this macoutreach.rock screen to ask for help, or you can email us at mcmasteroutreach@gmail.com. Okay, so the first activity is called Snowman in Space. For this, your 3D scene must include a light blue floor, no overlaid shapes, a space skybox, and then your snowman must include 3 white matte spheres stacked on top of one another, a matte red scarf, an orange matte nose, and a shiny black hat. So pause the video now so that you can attempt the challenge, and then come back. In about 5 seconds, I'll be taking up the answer. Okay, so this is one way that you could have made your snowman. So I started off with a sphere that has a radius of 15, it's matte and it's white. Then I have a smaller sphere and an even smaller sphere. And then I also moved these spheres up a little bit so that they were stacked on top of each other. Then I have a ring. This ring is a complex shape, so I had to make sure that I made a mesh for it. And then I just made it red, and again I had to move it up. Then for the hat, I used 2 cylinders. I just stacked them on top of each other. And because the hat had to be shiny, I made sure that I used a metallic material with a very low roughness. Lastly, I used a cone for the nose, and I had to rotate the cone. You could have rotated it in many different ways, but I chose to do rotate x3d by 90 degrees. Then I just had to move my nose so that it was oriented correctly. So that's how my snowman looks. For the floor, I just had to go to my floor code, and I just had to change the color dot green to color dot light blue. Then the last part of the challenge was to make a space skybox. So for that, I just used this last skybox option here, which is the URL spherical skybox, and then I just got a link from the textures document. So that's about it for activity number 1. You could have done it in a different way, this is just one way. Okay, time for activity number 2, called Snowmen Dancing in Space. So this time, your 3D scene must include a group called Snowman, and then one snowman that's moving in a large circle and the other in a smaller circle. We also want one snowman rocking in the X direction and the other in the Y direction. So again, pause the video, give this challenge a go, and then come back for when I take up the answer. Okay, so this is one answer to activity number 2. So here I have a group called Snowman, and to make a group in 3D, I just have to write snowman equals group 3D. Because I have a complex ring, a complex shape here, I had to use model.meshStore. So I had to pass in model into my snowman group. So up here in my entities, whenever I used my snowman group, it had to be followed by model. So then I had to move one snowman in a large circle and the other in a smaller circle. So to do that, I just used move 3D, and then I specified an X, Y, and a Z movement. And to move in a perfect circle, you might remember from lesson number 3 that I just need to move one direction according to sine and the other cosine. And to make it a perfect circle, I just have to use identical speeds and spans for 2 of the directions. In my Z, I left it as 0 because I want my snowmen to stay on the blue surface. I did the exact same thing for the other snowman, except the span is just smaller for the snowman because, like the activity said, one snowman should be moving in a small circle and the other in a larger circle. The last thing I had to do was I had to make one snowman rock in the X direction and the other in the Y direction. So to make the snowman rock in both these directions, I used rotate X 3D and rotate Y 3D. Then I just used a combination of sine with model.time so that it would rock back and forth instead of rotating completely around. Time for activity number 3. So it's basically the same thing as before, but this time we wanted to add in a sphere that orbits around the snowman. The orbit should follow the path of a perfect circle, and the Earth should include an Earth texture and a horizontal rotation. So again, give the challenge a go, pause the video, and come back when you're ready to take up the answer. Okay, so here's how I did activity number 3. Just going to rotate so that you can see the Earth here. Okay, so to do this, I first made a group called Earth, and because I was using a custom URL texture, I had to pass in use texture in my Earth group. I could do that, or I could paste this entire line in each time I use texture. Okay, and then for my texture, I got it again from that document, and I followed the example, just wrote load texture, and then the name of my texture, and then a link to the texture URL. So that's where I got my earth texture from. And then when I used my earth in my entities model, I rotated it in the Y direction, and then I moved it again in a perfect circle, the exact same way that I moved my snowman. So this time, all we're doing is adding in a satellite that orbits around the snowman. So the satellite should be made up of a brown box to make up the body, and then 2 dark brown cylinders attached to the body, angled upwards 45 degrees to the plane. Then, attached to these 2 cylinders should be 2 brown boxes, which make up the camera portion of the satellite. So again, pause the video, give the challenge a go, and then come back if you want to take up the answer. Okay, so for this challenge, I just had to add in a satellite that circulated around my snowman dancing. And the satellite had to include a brown box to make up the body, which I have here, and then 2 dark brown cylinders attached to the body, angled 45 degrees upwards to the plane. So looking at my satellite group, I have a box which makes up the body, and then I have my 2 cylinders here. So I rotated my cylinders using Rotate X 3D, and then I rotated them both by 45 degrees. So one's positive 45, one is negative 45. And then the last thing I had to do was I just had to move these cylinders so that they would line up nicely with the body. So it might be easier to make the satellite or make any sort of extra shape in another slot and then bring it into this slot. That way the snowman didn't get in the way or anything like that. And it was really easy for me to get that 45-degree rotation without having to worry about the physical orbiting of the satellite. So the last thing I had to do was add in the 2 brown boxes that made up the 2 camera parts. And I did that by just adding in boxes and then moving them up a little bit and to the right or to the left. Then for the satellite, I just had to put it in my entities model, and then I just had to rotate it and move it. So the rotation was optional, but I wanted it to look like it was filming everything, so I just made it rotate around, but you really didn't have to do that. There are obviously a bunch of other things you can do in the 3D slot, but I hope that by completing these 4 challenges you got a good handle on the primitive shapes, a good handle on the complex shapes, a good handle on the transformations, specifically rotating and moving, and rotating in the X, Y, and Z directions. And also, I hope you got a good handle on how to apply different textures to different types of shapes and the skybox. Okay, so that's the end of the introduction to the 3D slot. Thanks for sticking around until the end, and just a reminder, if you have any questions, feel free to use the mentor portal, which is on the bottom right-hand side of macoutreach.rocks, or feel free to email us.